This is exercise 2.8. So exercise 2.8. The question says a signal beam at 1400 nanometers is generated by parametric down conversion using a pump beam of wavelength 800 nanometers. What is the wavelength of the idler beam? So this is a question based on parametric down conversion, and in parametric down conversion we know that energy is conserved. So energy conservation and according to energy conservation we would have the following relation. This is the energy conservation relation, which says that the input energy is equal to the output energy, input being the pump beam, output being the signal and idler beams. So here the subscript P denotes pump, the subscript S denotes signal, and the subscript I denotes idler. So this can be rewritten as follows. So this is our energy conservation condition. Now we know that omega by K is equal to C. So this will also lead to the following condition. This is because omega is equal to C times K, K being the wave number or the magnitude of the wave vector. So we get, sorry, I wrote this wrong. This is now K is nothing but 2 pi by lambda. So we get the following. From here we can find out the wavelength of the idler lambda I, because we know wavelength of the pump lambda P, and we also know the wavelength of the signal beam, that is lambda S. So let us solve this question. Let us rearrange and rewrite some terms. Now signal wavelength is 400 nanometers, pump wavelength is 800 nanometers, this gives us the idler wavelength. So this is approximately equal to so we find out that the wavelength of the idler is roughly equal to 1866.67 nanometers. So we have solved this question where we were supposed to find out the idler wavelength given the pump wavelength and the signal wavelength.